Welcome, Hornets, and thank you for joining me today. I'm going to be going over the 6.2 Growth and Decay worksheet number 2. Please be aware this second worksheet is trying to help you to recognize the difference between the restricted growth exponential and the standard growth exponential, like continuously compounded, as opposed to Newton's law of cooling. All right? So be aware in this, what we are looking for is the rate of change, a rate proportional to the difference between the constant room temperature and the temperature of the coffee. This is giving us our temperature in terms of time is equal to, let me make sure you can see that, is equal to our constant times 20, and then we have plus or minus our temperature T. Now, be aware that this is always going to give us the same formula, and so I'm going to be working with my temperature in terms of time is equal to my ambient temperature plus CE to the KT power. Now, don't worry about minuses. If there's a minus for the constant, that will show itself, and we'll then write the minus. If we have a negative for our rate, it'll show itself, and we'll write the minus. But as of now, all we need is the sum. What we do know is that at time 0, so that was 2 minutes ago, our temperature was 81.4 degrees, which is a combination of the ambient temperature and our constant. That means that if our ambient temperature is the 20 degrees, then we have to have an additional 61.4 degrees times e to the KT power. It is from this that we will be able to use the information and find our constant of variation. Now, I'm going to do this on a separate piece of paper so it's easier for you to see. So just be aware that what we did was we had 81.4 degrees Celsius had to be the 20 degrees Celsius plus the C e to the 0 power. Because of that, we ended up subtracting, giving us 61.4 degrees Celsius equaled the constant. So we then have our temperature in terms of time is equal to 20 degrees Celsius plus the 61.4 e to the KT. We're then going to put in the 78.5 degrees Celsius has to be 20 plus 61.4 e to the k times, now remember this was 2 minutes past, and therefore we have 2k. We're now going to solve for k. I'm going to subtract 20, so I have that 58.5. I'm going to divide by 61.4, leaving me with the e to the 2k. I can then take the natural log on both sides. Equaling the natural log forces the 2k in front, and the natural log of e is simply 1 and goes away, leaving me to take 1/2 of the natural log of 58.5 divided by 61.4. This is k. We're now going to rewrite our equation. The temperature in terms of time is 20 plus 61.4 e to the t divided by 2 natural log of 58.5 divided by 61.4, the quantity. It is with this that I can now plug in the 2 minutes plus the 30 minutes for a total of 32 minutes from the time we began. I'm just going to plug this in, and with the 32 divided by the 2 natural log of the 58.5 divided by 61.4, I can now find my answer, and all I'm going to do is plug this directly into the calculator. So I have 20 plus 61.4 times e to the power of 32 divided by 2 natural log 58.5 0.5 divided by 61.4, close parenthesis, enter. And our temperature after 32 minutes is going to be approximately 48.31185 degrees Celsius, and I will let you round to the value you want. Now, question number 2 is trying to help you to realize that it is exceedingly different. In fact, very different. If you look, it's a compounded continuously. That means that our account, the rate of change of the account, is directly proportional to the amount in the account. And that gives me the dA dt is equal to Ka. We know this as our, let's use the amount after our time is equal to our initial investment times e to the kt power. Notice this is just our standard formula that we worked with in the previous worksheet. And so we can now put everything in. We know that 7.6 years ago we had $1,080.40. This was 7.6 years ago. And let's just get rid of that. We don't need that yet. We need our KT equals the amount in the account after time. Now, they tell us that we have $1,498, and this occurred 7.6 years to get to now, 1080.4 e to the 7.6 and our k. This is what's going to give us our constant of variation. And the constant of variation is going to have to be 1498 divided by 1080.4. We're going to take our natural log on both sides. That's getting rid of the e. And then we're going to divide by the 7.6. And this gives me k. Once I have k, I can now write the formula. A of t equals 1080.4 e to the, and now I'm going to put t divided by 7.6 natural log of 1418 over 1080.4. I can now take the 5.6 years. I have to add that 7.6. So that's going to be 13.2. And I can now find my amount in the account by just putting in 13.2. Here we go. 1080.4 times e to the power of 13.2 divided by 7.6 natural log of 1418 divided by 1080.4. We end up getting $1,732.57. So we have, and 57 cents. And this is after that time. Now I do want to just make sure that I got that correct. So I'm adding the 6, that gives me 8.2, plus the 5 is 13.2. And that is correct. Let's take a look at number 3, please. The rate of change is proportional to the difference between the constant room temperature 20 and the temperature of the coffee. Same thing that we have up here. T of T is equal to the ambient temperature 20 degrees. We have coffee that is 75.6 degrees, and therefore we have 55.6 e to the kt power. Now this occurred 3 minutes ago. So we're now looking at a time of 3 that gives us 71.4. So I have 71.4. I'm subtracting 20. I'm going to divide by 55.6, take the natural log, and then divide by 3, 1/3. This is then going to leave me with my formula. Temperature in terms of time is 20 plus 55.6 e to the t divided by 3 natural log of 71 minus 20 is 51.4 divided by 55.6. I'm now going to look at 3 minutes plus the 27 minutes from now will give me a total of 30 minutes. So we're looking at t of 30, and we're going to put in 30 for our time right there. This is giving me 20 plus 55.6 e to the power of, and now I'm putting in that 30 divided by 3 natural log of 51.4 divided by 55.6 and hit enter. I'm looking at a temperature of 45.3488 degrees Celsius for the coffee. Let's take a look at number 4, compounded continuously. So compounded continuously is my account, or balance, is equal to the initial account, or the principal, times e to the kt. We know that our principal 8.3 years ago was $1,305. We are looking at kt power equals a of t. We're now going to use that 8.3 as our time. So 8.3 times k, e. We have 1305, and we are told that we have $1,702. So we're now going to put this in. 1,702 divided by 1305, put the natural log in front, and divide by 8.3. We then have the account total is equal to 1305 e to the t divided by 8.3 natural log of 1702, 1305 in the denominator, and we can now put in our information. Now, I need to go 7.1 years from now, already having gone 8.3. So we are looking at 15.4 is the time that we put in here. We're using our calculator now, and we're going to do exactly as we see it. 1305 times e to the power of 15.4 divided by 8.3 natural log 1702 divided by 1305 and hit enter. The amount in the account after that period of time, 15.4 years, is $2,136.149. And I'll let you round it to 1.5. And that is our answer for number 4. Alrighty, if you have any questions, please remember to come in and ask. Otherwise, Hornets, I hope this has helped and has kind of given you a little bit of the insight into the 2 different types of equations that we are trying to work with: exponential growth and decay, and the idea of restricted growth. Thank you very much. Please be well and be safe. Take care, and we will see you when I see you next. Thank you and goodbye. Please remember to click like if you felt this was a useful tool, and put any comments if you think you have suggestions to help me. Thank you very much and be well. Bye-bye now.